We can get going. All right, good morning. We're going to get started. And hopefully the unit section 1.1, I really feel like is going to be a lot of review. And so we're just going to quickly go through it. If there's something you need us to pause on and give more explanation, I certainly can. But I'm going to kind of go through it fairly quick. Lee, I hope that you will have an assignment that should be listed as 1.1. What I do on my assignments is I try and give you plenty of time. So in other words, I put the due date as the 19th, which is September, or January 19th was a Sunday. I do extend that so that if you need longer than the 20th, because I know some of you work and some of you have extra work, you do other things outside. I would rather you complete assignment late than not complete an assignment. And my goal would be that you have all assignments for that unit. So when we do the Chapter 1 test, that you have all of the assignments done at that point. But again, I kind of give you some guidelines so that you can get them done. But again, if you don't, I would rather you finish them at a later time. So with that started, we're going to start with coordinate system. So this is a rectangular coordinate system. Some of the terms, the middle point is always the 0, 0, 0 is going to be your origin. We're going to talk a little bit about, when you look at the origin, and I'm going to say we have 0, 0, then that's also referring to the fact that that's the x value and the y value. So the very first one is always your x value. The second one in your coordinate system is going to be your y value. And it'll show you directions. Now, quadrants, when x is positive and y is positive, is going to be quadrant 1. And then it actually changes, it rotates around counterclockwise. So quadrant 2 is when x is the negative value but y is positive. Quadrant 3 is when they're both negative. And quadrant 4 is when x is positive but y is negative. We have two axes that are defining it. Y is always going to be your vertical axis, where x is always going to be your horizontal axis. Other than that, are those all features that you know of, Kirsten, before? Okay, I figured it would be. So, going on, the first thing we're all going to do is also go ahead and do the order pair. Again, I talked to you about earlier that it's going to be x comma y. And so when you plot -2 comma 4, you're going to go to the left 2 and then up 4. So in other words, this is going to be your x, the movement on your x, and this is the movement on your y. So tell me, Kirsten, tell me how to plot A. You have -3 comma +5.
You go to the, wait, hold on.
Sorry.
Okay. You go to the left 3 and
Uh-huh.
then up 5.
Perfect. 1, 2, 3, 4, 5. Left 3, up 5. And then usually you will mark that since it is identified as A, then you can just put the A beside it. So when you guys will do your test and your homework for the very first unit, that's kind of what I'd like to see. Do 2 -4 for me.
To the right 4 and up 2.
Close.
Oh my
Yeah.
gosh.
It's okay. I got it. To the right, 2.
And then down.
Yep, and down 4. And then this would be the point B. Keep in mind, if you have a point that is on your axis, so if you have 5 comma 0, that means you'll go to the right 5, and then it'll stay on the axis. So this is also have a special name that we're going to talk about a little bit more. What is that one called? If it is the point 5 comma 0, it's also your intercept. You got it. And this one is be your x-intercept, which is also, I guess that's a little foreshadowing. Do you guys ever do foreshadow? In English? Is that your, I guess your little tease. All right, and then the next one, if you have 0 comma 4, so you're going to stay at you're going to stay movement on your x is 0, and then you're just going to come up 4. And then if this was, the C was your x-intercept, then point E would be your y-intercept. And then, of course, the last one would be 0, 0, and that's going to be your origin. And that would be F. When we do functions, a function, and we'll talk more about this as we get along, but function means that Every member of the domain, which are your x values, has a unique member of your y values. When you have a linear equation, and I know this is linear, there's some clues. Okay, one, it's kind of in a form that you probably recognize. Do you recognize that form from?
Yeah, but I don't remember.
It's okay. Okay, if you've probably seen it before as y equals mx plus b, and that one is going to be called your slope-intercept form. Okay, so they've given you a relationship that's going to be starting with y. We're going to talk about what happens when we let x equal one of these values and you substitute it back into y. We're gonna find each of the ordered pair that it's associated with. I know this is a linear equation, partly because of the fact that the y is to the first power and x is to the first power. Even though there's not a 1 there, we automatically assume it's there. And when you have a first degree equation written, then you'll always have a linear equation. We're going to get into a lot with parabolas like we did in modern college math. And you know that one of those will have to be a squared. So let's jump into this one. If I have x equal -3 and my equation is y equals 3x plus 2, then what I want to do is I want to find y, and I'm going to take 3, times, I'm going to substitute the x and I'm going to change it to -3 and then add 2. So 3 times a -3 would be -9. What's a -9 plus 2?
So seven.
-7. So if I have x here, then I know that my y then is equal to -7. So my x, my order pair would be a -3, -7. And then I'm going to do that with each of my points here before, and then I'll plot them. So I'm going to, just to save some time, let's just jump down to -1. So y equals, I'm going to have 3 times -1, and then I'm going to have plus 2. And so 3 times -1 is going to give me 3 plus 2. -3 plus 2 is going to be a -1. So in the point, I have an order pair of -1, -1. I'm going to go ahead, when x is equal to 0 is kind of nice because it makes it super easy, and that's one that I always suggest picking because you're going to have 3 times 0 plus 2. Well, 0 plus 2 is just going to be 2, so I have my intercept. And that's also, if you recall from our y equals mx plus b, then that would make sense that 2 is going to be the b, which is also our y-intercept. So I have the point 0, 2. And I'm going to do one more positive one, and just to finish out, so I'm going to go y equals 3 times 3 plus 2. And so in this case, I have 3 times 3, which is 9, plus 2 is going to be then 11, and so I have the point 3, 11. Now, when you come over and you're asked to plot that, I'll try and be careful. I try and give you, if I have 3, 11 that I've asked you to plot, I try and have it in there, but if not, you just have to extend it out and make it work. So let's go ahead and plot -3, -3, 1, 2, 3, 4, 5, 6, 7. I have the point -1, -1. I have the point 0, 2. And then I have the point 3, 1, 2, 3, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And let's just get it one higher above, and it's 11. Now, in this case, since I know that it's first degree and it's a linear, that means it should make a line. Let me do a real quick straight edge. If something did and these did not line up, then something went wrong. So, wow. Hopefully you had a better straight edge than a sticky note. So they did line up. Now the next equation is a little different. Absolute value equations, okay, in general. I'm going to talk a little bit about what they call the parent equation. And so the parent equation means that it's the standard without any shifts left or right, or like any stretches, you know. And so in this case, my parent equation for y equals the absolute value of x minus 3 is just the absolute value of x. All of these, okay, this parent equation always will look like a V. In other words, when I have a value, when x is positive, and I take the absolute value of it, I just get a positive number back. Absolute value is defined as the distance a number is from 0, and the distance is always going to be positive. So even, I always like to think about a football grid. Even if I have a negative, like, so say the quarterback got sacked behind the line of scrimmage, then you had like a negative amount for his yardage, but it's still a value that's so he sacked 5 yards the ball out of the line of scrimmage, which would be a -5. But when you take the absolute value, but the distance still is going to be 5. And so when I have a negative, it's going to change to positive, and that's why on all absolute value equations, they're going to resemble a V. But in this case, I have a V and I'm going to have a -3. And so what happens is that's going to have a shift with it. So let's start off with the first one. So I have y equals the absolute value of -3 minus 3. So in this case, the absolute value of -3 is just 3 minus 3, and that would end up being 0. So my first order pair would be -3, 0. And I'm going to go ahead and go -3, 1, 2, 3, and I'll have the point 0. If I continue on, let's do just a couple more points when y is equal to 0. I would like, when you do your homework, you have to fill those in, but let's go ahead and do, when I have the absolute value of 0 minus 3, the absolute value of 0 is just 0, and then minus 3, then it's going to be -3. So I have the point, then 0, -3. I'm going to jump down, I know, just to give me a couple points to hurry up. So y equals the absolute value of 3 minus 3, and then in this case it's going to be then 3, the absolute value of 3 is 3, minus 3 is then 0 again. Keep in mind, a lot of where I see errors is when people switch the signs. So in other words, they take a positive number in here and they make it negative. And that's not the case. It just means that you're always going to have a positive number back. When I taught in junior high, I used to have a sign, the absolute value attitude, when you came into my class, just because I always wanted you to have a positive attitude when you came to class. So in this case, I'm going to have then the point 3, 0, and I'm going to go ahead and plot all of those points. I'm going to go 0, 1, 2, 3, and then I know that I'm going to draw my V-shaped graph that has a shift that goes down, and we'll talk more about the shifts and the stretches at another time. Okay, now we get to our parabola. I know it's a parabola because of the fact that I've got a square, okay? And so I know that it's a U-shaped figure, so my parent function for y, for this function, anytime it's y and there's an x squared, will be y equals x squared. This one looks a little bit like a U, okay? It's different than the one we had before. And then this is going to be one that's showing that we have a shift, and we also will have a flip. So because of the fact that it's negative. So let's go ahead and just jump in and go y equals, we're going to have 5, we're going to have negative minus, then we're going to have a -3 squared. Now, I've seen some errors with the negatives and squares. Remember, when you substitute a number in, make sure that you think about it being in parentheses. I know when I get down to the positive numbers, sometimes it's easy not to put them in because they really don't matter. But this one does. This tells me I'm going to take a -3 times a -3. That makes it positive. So then I end up with 5 minus a +9, which is then going to be then -4. So my ordered pair would be then -3, -4. If I go ahead and let's do 2 more. I'm going to do a -1 just as a practice. So y equals 5 minus, I'm going to have a -1 squared. So a -1 times -1 would be +1. So I actually have 5 minus 1. And 5 minus 1 then is going to be, in this case, just 4. So I have the point -1, 4. When I have the point 0, in this case, I'm going to go y equals 5 minus 0 squared, and that's going to be the value of 5. Let's do one more, and then I think we'll have enough to go ahead and graph. Y equals, I'm going to have 5 minus 3 squared. Now, keep in mind on parabola, when I square this, I'm still going to get 9. So I have 5 minus 9. That's still going to give me that -4. And that's what I'm going to see where I might have some symmetry. So I have the point 3, -4. Let's plot those. So I have -3, 1, 2, 3. I have -4, 1, 2, 3, 4. If I have +3, I also have -4. I also have, whoops, I didn't finish this one, 0, 5. So I'm going to go 0 and then go up 1, 2, 3, 5. And I also plotted the point -1, comma, +4. 1, 2, 3, 4. And that would indicate when I put my symmetry that I'll also have when x is 1, it's also going to be 4. And so I have an inverted parabola, and that starts with a vertex point of 0, 5. Negative. Any questions on that part? Good? Okay. The next one is going to be identifying your x-intercepts, and that's where I gave you a little bit of a tease. Remember, the x-intercepts and the y-intercepts are going to be where it crosses the x-axis. So the x-intercept on this one, here's my x-axis, has to be this point right here where it crosses. Now to write that, especially on your computer assignment, they a lot of times will just have you write -3. Sometimes I'll also ask you to write me a coordinate, just so we have clarity. So if I ask you to write the coordinate point for this, you would tell me it is -3, 0, because my y value is going to be 0. Anytime you have an x-intercept, the y value is going to equal 0. When you have a y-intercept, that means your x value has to be 0, and that's going to be the place it crosses your y-axis, which is going to be right here. So you would write it as the x-intercept is, and you would put then 5, or the coordinate point, which is going to be then 0, 5. Questions on that? Okay, perfect. Okay, is it possible to graph the relationship with no x-intercepts or multiple x-intercepts? And the same is true for y-intercepts. So in other words, if I'm identifying the intercepts, now keep in mind, anytime you're asked to identify intercepts, you're talking about both x and y. So in this case, I'm saying, well, it's not going to cross the x-axis, so that my x-intercept is nothing. It's a null set because it doesn't ever cross, and so you won't ask for that. But there is a y-intercept, and my y-intercept is going to be the place it crosses. In this case, it's going to be then y-intercept of 4, or the coordinate point, or at the point 0, 4. Okay, identify for me let's start with the x-intercept. Can you tell me, Kirsten, what is the x-intercepts on this one?
Here, 2.
Yep. So you can write it as x-intercept of -2, comma 2, and when we get to where we're writing our our interval notation, it kind of can get a little confusing. So sometimes I will ask you for the coordinates. And the coordinates then would be then -2, 0 and 2, 0. Okay, my y-intercept. Yep, 3, which is the coordinate. Yep, 0, 3. Okay. So on this one, the last part is interpreting graphs. So line graphs are also mathematical models. In other words, a lot of times we give story problems to represent different kinds of the models or different kinds of problems. And so you have to interpret those a little bit. So when I look at this, okay, I have 2 line graphs that are showing the percentages of marriages ending in divorce after 5, 10, and 15 years of marriage for the 2 levels of education in their placement. So if you look, the red line is going to be then the high school, the amount of degree they have was just high school or no college. And then below, the blue line is going to represent someone who went to school and has a bachelor degree or higher. So in this one, tell me, what is your think? What is the obvious conclusion that you get from that graph?
People in college get divorced more.
Okay, that's what. So she said people with not a college would have probably a higher divorce rate, and she's correct. You could also define it as the opposite. Just say the people with a bachelor degree typically have a lower divorce rate, which is saying exactly the same thing. So during which 5-year span is the person who didn't go to college, and so again we're talking about this one, most likely to get divorced. And so in this case, if you look at the it says you have the percentages getting divorced, so you're looking for the highest percentage. So if I'm looking for the highest point, which is here, And so I'm going to follow it back over, and it would be then the 35, and then again it's the percentage. I'm sorry, 35%. According to the graph, 25% of the people with a bachelor's degree divorced by how many years of marriage? Yeah, so go follow here, and you're going to cross over, and you're looking for the bachelor degree, and she is correct with 10 years. What percentage of married couples who did not go to college get divorced by how many years? What percent of married couples who did not go to college get divorced by that many years? So, in this case, married couples who did not go to college, I'm looking at this one, and I'm going to say get divorced by that many years. What?
Like, how many, like, what percent are they at 10 years?
Yeah, 10 years. Oh, yeah. Okay, so at 10 years, so you would then come over and say 30%. Thank you. I was not reading that. I think I'm sleepy. So, all right. Look for your assignment. Email me, RJ and Emma, if you are having problems accessing your assignments. Tomorrow's a work day, possibly. I think I may go ahead since we didn't. I'll see how things go and see how you're getting, if everything's getting started. Okay. And I may go ahead and move up the lesson. I may adjust. Maybe I'll just keep it this way. Give you a work day tomorrow, and then on Friday we'll have another lesson.